What if I told you that some rocks were once alive, and entire mountains were built from shells, skeletons, and ancient seas? This is limestone, not just a rock, but a geologic archive of life, climate, and oceans. Limestone is a sedimentary carbonate rock composed mainly of calcium carbonate, typically in the mineral forms calcite or aragonite. It forms at or near Earth's surface, and unlike igneous rocks born from fire, limestone is born from water, biology, and chemistry. Limestone forms primarily in warm, shallow marine environments, places where life thrives. Key formation pathways are biogenic, which consists of the accumulation of shells, corals, foraminifera, and algae. Chemical, and this is a direct precipitation of calcium carbonate from seawater. Biochemical, in which microorganisms trigger carbonate deposition. Think tropical shelves, reefs, lagoons, and carbonate platforms where it is like clear water, low clastic input, and high biological productivity. Limestone isn't one thing, it's a family. Major types include fossiliferous limestone with visible shells and skeletal fragments, chalk, a soft white limestone made of microscopic calcareous, coquina, consisting of loosely cemented shell fragments, micrite, and this is fine-grained carbonate mud, oolitic limestone, which is composed of tiny spherical grains formed by wave agitation. Reef limestone, there is a massive framework building carbonate from coral reefs. Not all limestone forms in the sea. Travertine is a freshwater limestone precipitated from carbon dioxide-rich spring waters, often forming rapidly in terraces, caves, and hot spring systems. Each type of these limestones tells a different environmental story. Limestone dominates passive continental margins, epicontinental seas, carbonate platforms, and ramps. Structurally, limestone is famous for karst landscapes like caves, sinkholes, underground rivers, tower karst, and limestone pavements, all of which form through chemical dissolution by weakly acidic water. Limestone is one of the most economically important rocks on Earth. It's used for cement and concrete production, building stone and aggregates, steel manufacturing, agriculture as a soil conditioner, glass, paper, paint, and chemicals. The scientific significance of limestone can be represented by it records ancient climates and sea levels, it preserves fossils and evolutionary history, it hosts groundwater aquifers, it controls carbon cycling on a planetary scale, in addition to the fact that it forms major hydrocarbon reservoirs in many sedimentary basins. Limestone exploration focuses on identifying thick, laterally continuous, high-purity carbonate units. Geologists begin with regional geological mapping and stratigraphic analysis, supported by remote sensing and satellite imagery, to trace carbonate platforms and reef belts. Geochemical sampling determines calcium carbonate content and impurities such as silica, magnesium, or iron, while geophysical methods, especially seismic and ground-penetrating techniques, help define subsurface continuity. Ultimately, core drilling and quarry-scale evaluation confirm quality, thickness, and economic viability for cement, aggregate, or industrial use. Limestone is not just rock, it's time-solidified, oceans turned into stone, a life written into geology. To understand limestone is to understand Earth itself.